So we're going to continue our work with the chain rule, but we're gonna turn it into a little bit more of a challenge today, because we're going to do the chain rule in combination with other rules. So we're going to do the chain rule with the product rule. We're going to do the chain rule with the quotient rule, and we're also going to do chain rule twice, so you can see what that looks like. All right. So here's our first example. Here, go ahead and write down example 1.
Right.
So when we're looking at this here, you guys, what do you think? Is that going to be product rule or quotient rule? Product rule. It could be product. Can somebody explain why it could also be quotient technically? Yeah, so you could rewrite that right as a quotient and do it differently. I'm gonna keep it as a product rule for now, but yeah, it could be a quotient technically. And you would get the same answer regardless of what method you used to get there. All right, so we want to find the derivative of this. So derivative, I need to calibrate my pen just a second. It's not on point. Okay, so the derivative of a product, right? We start by doing 4 blanks. And just for the heck, you don't have to do the A-B thing. I'm just doing that for teaching purposes. But you have the first piece, the first factor, which we'll call A, the second factor we'll call B, and both ones go in those slots, right? And then you make one of them a derivative on the first set, you make the other one a derivative on the other set, right? And so here we go. What's the derivative of A? I'm sorry, yeah, derivative of A. 4. Some parentheses around that. And then we're going to go ahead and write B, which is just stays the same. Not doing anything with that, it's just B. Over here we have plus A. That's just A, right? So we're going to write 4x plus 3. And over here we have B prime. So this is where I need to do what? That's a chain rule, right? Because I've got an inside function and I have a outside function. So the chain rule, which we learned yesterday, is the derivative of the outside, don't change the inside, multiplied by the derivative of the inside. So my outside function is something to the negative 3. So what would something to the negative 3 be if I took its derivative? Good. So it's going to be negative 3, parentheses negative 4, and what goes in the parentheses here? Yep, it doesn't change. And then we multiply that by the derivative of the inside, which is 6x. So that's it. So you guys can see we have to do 2 rules at once, right? Part of the product rule here is a chain rule. Oh yes, it would. Thank you. You're correct. Now, how would it look on a multiple choice test? Well, there's a lot of ways it could look, right? They might rewrite this with the negative 3 in the denominator, right? They might move that whole piece to the denominator. I think it would look probably like this, though, would be my guess. The negative 3 and 6, I think they would put those together. What's negative 3 times 6x squared? Negative 18. So I think they would drop the plus there. And I think they would just change it to negative 18x squared, and then they'd have the 2 parentheses after that. That's what I think you could expect to see, but I'm not sure. So basically, in case you guys haven't noticed, I think the only thing that they usually do is just go and multiply those numbers, because the monomials together. But you know, be prepared for other things like moving that to the denominator and stuff like that. All right, so that's one application of the chain rule in combination with something else. Let's continue here. Okay, so what rules do you guys see here? You see quotient rule, and do you see the chain rule? Okay, so this one's kind of interesting. What rule would we do first? Quotient rule. So let's look at that really quick. I think we would do the chain rule first. Now here's why. I know in the last one, I did product rule first, right? But let's compare and contrast these. What's different? Well, what do you guys see the inside function here? It's that whole quotient, isn't it? So I guess this is a good way to say it. Since the quotient is the inside function, then you're going to start with the outside first, right? And that's a chain rule. Does that make sense? So we start with the outside first, and the outside is just something to the -2, right? So you always want to start with the outside thing first. And in this case, the outside is going to make you have to do the chain rule first. Whereas if we back up for a second here, let's look at the one that we just did. Where's our chain rule? Right. It was here, right? Is that the whole thing? Is that like the whole outside piece? No, it's not. It's like, so the chain rule is actually inside. It's a part of the problem. So you do the outside first, which is the product rule. Chain rule is inside the process there. Whereas over here, on this example that we're working on, the quotient rule is the one that's on the inside. So you actually start with the chain rule first, okay? And so let's do the chain rule first. We said that this was the outside function, right? So what would that be? What would I put here? -2, and then I'm going to have parentheses. And what's going to go here? -3, right? So we move the x1 to the front. We take one off here. And then our inside is going to stay the same. So that's the derivative of the what? The outside. Times the derivative of the inside. Now, how do you find the derivative of that? That's the quotient rule. Okay? So it's going to be low d high, which is what? Minus high d low good. Draw a line and square below. There you go. I don't foresee this being simplified in any meaningful way at all. I'm not going to do it. And I wouldn't ask you guys to do that. It's just kind of like a waste of time. So we're going to leave it like that. But there it is. So in this case, the inside function was a quotient rule, so we started with chain rule. Over here, the inside function was the whole thing was a product rule, and the chain rule was inside the product there. So we started with the product, and then we did the chain. So you gotta, it's about which one is outside, which is the one you do first. So here's two. They're very similar to the one I just did. Simplifying is not required. Go ahead and see if you guys can knock those out real quick. All right. There's my cards here so I can call on people. So let's start with, Jonathan's not here today. Neither is Mateo, but Walter's here. So Walter, what rule do I start with first on number 1 here? That's right. And this is how you start your power rule. Did you say power rule? Product rule. the other piece. So that's how you start your product rule. Jimmy? Well, I'll label these. It kind of helps. Okay, so Jimmy, what goes here then?
I put 8x.
Okay, so you did. Oh, that's right. Cool. All right, that'll work. And how about here?
Just the like it just stays the same, right?
Yeah. Okay, so the B's just stay the same. How about here?
That one just stays the same as it.
And this is where what happens, Jimmy?
The chain rule.
Cool. So I'm going to ask Michael. Michael, when we do the chain rule, what do we get here? Okay, good. So that comes from taking your power and sliding it to the front, right? And what goes in here? And how about up here? Good. So we subtract 1 from that. And then what goes out here?
20.
Good. I saw 3 people, okay? And I know you guys know better. Just a lot to remember. So you're just kind of mixing the ideas up. But I saw 3 people putting 20x cubed in here, right? And 2 of those 3 people, because of that, put 60x squared out here. Does that make sense? So they took the derivative of this and put it here. But remember, we don't change the inside, right? But they took the derivative and put it here. And then they took the derivative of that again and came up with 60x squared together. So remember, chain rule, you don't change the inside when you do the derivative of the outside. So there's that. Some of you guys took the extra measure and went ahead and multiplied 1/5 by 20 and got 4. That's cool. That'll work. All right, let's go ahead and move on to the next one there. Matt, what do we start with on this one? That's right. And so my outside function is this. So Matt, I'll let you go ahead and tell me what to write for the derivative of the outside here.
4.
Uh-huh.
With that entire.
You don't want to say it? Are you sure? All right. And what goes up here?
Q.
Good. All right. We'll stop you there. And then, Andrew, here we do the derivative of the inside. And so what rule do we apply here?
We apply the chain rule with the quotient rule.
It's the quotient rule, right? So we're doing we've done so the chain rule is outside, inside, and the inside part is a quotient rule. So we do low d high minus high d low, draw a line and square below. I'll go ahead and just do that real quick. So low d high minus high d low. Is that 8x? Draw a line and square below. And we can leave it just like that. Pretty ugly, but there it is. Okay. So that's chain rule in conjunction with other rules. Yeah. What does what disappear? So chain rule, right, we do the derivative of the outside, correct? Now the outside function is something to the 4th power, and so the 4 goes to the front, and you take 1 off the power. That good?
Yeah, well, I saw the right stuff. I was just...
Okay, good. Oh, so you don't want me to get any credit for that? It wasn't any of my words. I didn't help you at all. So I should just leave. All right. All right. Chain rule twice. This happens when you have a function inside of a function inside of a function. Your head went the wrong way. It's supposed to go like this. You're broken. Try again. All right. All right. Let's do it. So this is like when your robot is driving your airplane, your robot gets a virus. Okay, so we have an inside function, a super inside function. Then we have a medium inside function, and then we have an outside function. What should we call the medium inside function? I don't like calling it medium inside. I know. Let's use the egg, right? We have the yolk, and then we have, what's the white stuff called?
Egg white.
Egg white. So we have yolk, egg white, and then we have shell. You good? We have really inside, a little more around, and then, yeah?
What white part? When you harbor on Eve.
Okay, I don't know why that made me laugh, but it did. All right, so what's our yolk? What's the super inside part, the deepest part of
Yellow
it?
part.
Here's our, yeah, the yellow part. I won't write in yellow because yellow is hard to see. But yes, there's my yolk, right? That's the really inside part. Now, what's the egg white that surrounds it? This is kind of a toughie. So it's inside this, right? +1. That purple part is our egg white. So this guy is plugged, the green one is plugged into this purple one. You guys see it? Now what's the purple one plugged into? What's our eggshell? It's the something to the third power, right? There you go. So we have our yolk, our egg white, and our shell, and it's derivative of the outside times the derivative of the inside, right? But we're dealing with an egg here, so it's the derivative of the shell, don't change the inside, multiplied by the derivative of the egg white, don't change the inside, multiplied by the derivative of the yolk. Are you guys ready? It's not bad. It's just you multiply one more thing, really. So here we go. My egg white is something to the third power. So what's the derivative of something to the third power? 3 in the front and 2 here. The rest, don't change the inside. Don't change the egg white. And don't change the yolk. Stays just the same. So we did the derivative of the shell. Now we're going to do the derivative of the egg white. All right. So let's take a look at the purple part here. If you took the derivative of this purple egg white here, what would that be? Okay, so 4 to the power of 3. What happens to the 1?
0.
Goes away, right? And don't change the yolk. Multiplied by the derivative of the yolk.
Negative.
Yep, negative 12x cubed. Oh, squared, you're right, my bad. Squared. So, eggshell, white, yolk. Nice. Yeah.
They're all multiplied?
Yes, everything's multiplied together. So if you wanted to simplify this, what 3 things would I want to put together? The negative 12x squared, the 4, and the 3. So this is, you'd probably put these 3 together. So that's going to be 12 times negative 12, which is, I'm not going to write the whole thing again. But it's negative 144x squared, right? Hey, Jimmy.
So you for this, like the egg white part or whatever, you take it outside the parentheses.
Say your question again.
So like you would take it outside the bigger parentheses, the shell.
So when you take it out, it's the derivative of it, right? So the one that's inside still doesn't change. So notice that the eggshell stayed the same, or sorry, the egg white stayed the same here as it did up here. But as soon as I get that purple out there, now it's a derivative. Does that make sense?
Yeah.
Okay. All right, same thing here. Yoke stayed the same, but as soon as I take it out, it's a derivative now. All right. So I have yes. It's a good question. This is another example of something that honestly I don't think you'd see very often. So why am I giving you problems like this? Well, because first of all, the time you would see, they're actually easier, but we haven't learned those derivative rules yet, so I can't show them to you. So we're sticking with the stuff that we know. You probably wouldn't see much of this, honestly. Like, I've never seen anything like this on an FRQ, and close maybe in multiple choice, but it's really more like the ones that I said we're not ready for yet. So I wouldn't stress about that. This is really just getting you guys used to the rule. We'll get to the AP kind when we can get there. All right, so before I throw a harder one at you, I want you guys to try this. My student practice here is a little tough, so I'm just going to give you one just like the one we did. Let me use black here real quick. So
Is this student practice?
yeah. All right. So why don't you guys try this really quick? But before we do, let's talk about it as a class really quick. What the egg white, egg yolk, and shell is. So Nick, what's the yolk?
The yolk is the x 8x minus 3 to the 6th power.
Good. So I'm gonna use green for that. 8x minus 3. And did you say to the 6th power?
Yeah.
That's actually not part of the yolk. It's just the one in the parentheses.
Oh yeah.
All right, so next, I'm going to come to Orion. Orion, what's the egg whites?
Oh, the 6 and -5.
There you go. So it's the something to the 6th power minus 5. And did I throw an extra parenthesis on there or something?
Oh yeah. Yeah. All right.
I did. Yeah, let's get rid of that parenthesis. That doesn't need to be there. All right, and from there we have Caitlin, what's the shell? Yes. All right, so there it is. So why don't you guys go ahead and see if you can get that real quick. So I put a prime here. I shouldn't have that there. If you guys noticed that or not, please catch me if you see me doing that. So they what should I write first? Uh-huh. Okay. And then what's here now? 1, right? Which we don't need to write, correct? Okay. And so that's the derivative of the shell. Don't change the inside. There's that piece, right? And then from here, we're going to put times. And now we're going to do what comes next, Zarina. Good. So that's the derivative of the egg whites, right? So there's that other piece. And then we have the last piece. Amanda, what comes last? Times what? Just 8, right? And then, so Andrew, you and I were talking. So there's that one of the pieces that I circled, right? There's the other piece that I circled. But I think that you might have kept the -5. We do want to get rid of that. I think I forgot to mention that. And then you have your 8, 6, and 2. Those 3 things put together make that 96 that you had. So he put those together and got 96. So. All right. So I don't know if we have time for another one, but we have time to start it because it's the start that'll be the issue for you probably. Okay. So I'll leave that up there in case you guys need to write it. And proceed. So I'm glad to see you guys are getting chain rule pretty good in here. It's very important. That and the power rule are like we'll be doing them all year. This is like extra. So you guys got this. I know you got the basic idea. That's pretty good.
Usually, or every class is for everything?
No, they're pre-cal. Different class. All right. Let's see. So here's the other thing. So what do you think I'm going to say we need to do here? We don't like roots, right? We like to change those into powers instead. Now you guys see that the root only applies to this piece here, correct? So that part is going to become a what instead? It's going to be negative 4 plus 5, but to the power of 1/5. After that, there's really nothing different. Okay? So it's really just, you know, with the roots, make sure that you rewrite them. And that's that. Okay? I think, do you guys want me to try to knock it out? What time is it? 2? I'll work. If you don't want to write it, you don't have to. If you do. So, what's my yoke?
Negative 4x squared plus 5.
I'm going to use yellow. I'm doing it. I know. I live dangerously. What is my egg whites?
1/5 minus 5.
Something to the 1/5 power minus 5. And then my shell. So derivative of the outside. Negative 4, right?
Yeah.
And what goes here now? I don't know if I've lost my audience or confused. It's negative 5. It's okay. You don't have to pay attention. I know you guys got to get going. Inside stays the same.
Yep.
Times. All right, guys. I'll see you later.
But you really, can you keep it up there for
Yeah.
time being?
I'll keep the whole thing up there for a while. I'll finish it too. Bye, guys. Have a good day.
Oh, what? Oh.